And welcome back to section 5.2. Let's do one more example of using a matrix to solve a system of equations. So as you know, the first step is to write the system as an augmented matrix. 3, 0, negative 6, 48. And notice that it's 0 because of don't have a y variable. So we have the x column, the y column, and the z column. So make sure you put in a 0 for that y. That's a common mistake. Next row is 1, 1, negative 1, 4. Next row is negative 2, negative 1, 2, negative 20. All right, so there's our augmented matrix. And the first order of business is to make this number be a 1. So there's several ways we could do that. We could do row 1 divided by 3, because we wouldn't make any fractions that way. We could also do row 3 plus row 1 and do that. Or we could even do negative 2 times row 2 plus row 1. So there's actually 3 different ways we could make a 1 right here. And it doesn't matter which one you pick, because as long as you follow the rules till the end, you should get the right answer. So I'm going to go ahead and divide row 1 divided by 3. So row 1 equals row 1 over 3, just because I think that's a little easier. So row 1 becomes 1, 0, negative 2. 48 divided by 3 is 16. And the other two rows stay the same. Just like that. So there we go. Next order of business is we need both of these numbers to become zeros. So let's do row 2. If I just do row 1 minus row 2, or row 2 minus row 1, I should say, then we'll get zeros there. So we'll replace row 2 with row 2 minus row 1. And by the way, I don't like writing this in terms of subtraction because I think it gets a little confusing. So I always like to add. So I'm just going to add a negative row 1. Okay, so it's the same thing as subtracting, but to me addition is easier. So row 1 stays the same, so let's write that just to keep this simple. Okay, so negative row 1 and add it down. So negative 1 plus 1 is 0. Negative 1 times 0 is 0. So when we add 0 plus 1, you get a 1 there. And negative 1 times negative 2 is 2. Add it down and you get a 1. And then if we do negative 1 times negative 16 and add it down, we get negative 12. So again, we did negative 1 times row 1, added it to row 2, and used that to replace row 2. And the third row stayed the same. Okay, so what should come next? Well, now we need this to be a 0. Okay, so how do we make that negative 2 become a 0? I would do row 3 equals row 3 plus, and let's just do 2 times row 1, because 2 times 1 is 2, and when you add that down, you get a 0. So row 3 plus 2 times row 1. So start by writing the top 2 rows, because we're not changing them. It's a good idea to do that, because then you don't make accidental mistakes or change a number you're not supposed to. So always write down the rows you're not changing first. So 2 times 1 is 2, add it down is 0. 2 times 0 is 0, add it down, you get negative 1. 2 times negative 2 is negative 4, add it down, we get negative 2. 2 times 16 is 32, add it down, and we get a 12. Okay, so we've got 1, 0, 0, which is good. Next thing we need is to have a 1 here, and we already have a 1 there, so that's nice. So now we need this to be a 0, this negative 1 right here. And I see that we can do that by just adding row 2 and row 3 together. So we'll do row 3 equals row 3 plus row 2. Okay, so we'll replace row 3 with row 3 plus row 2. So let's do that up here. Okay, so row 1 stays the same. 0, 1, negative 2, 16. Row 2 stays the same again. 0, 1, 1, negative 12. So what's row 3 going to be? 0 plus 0 is 0. 1 plus negative 1 is 0. And 1 plus negative 2 is negative 1. And negative 12 plus 12 is 0. And so now we're pretty much almost done because we have 0, 0, negative 1, 0. So that means negative 1z equals 0, or we just divide both sides by negative 1, z equals 0. So that's cool. That can happen sometimes. It's perfectly okay. And now we're over the hill because now we're going to be able to find y and z pretty easily. So you can use any row to find y now, but you should use any row that only has a 0 for x because we want to find y. So let's use this row right here, which is 0, 1, 1, negative 12. So that's no x plus 1y plus 1z equals negative 12. And we know that z is equal to 0. So that's y plus 0 equals negative 12. So y equals negative 12. Okay, so that's really good because now we have z and y. So now we just need to find x. And you can use any row to find x as long as there's a number here for x. So I'm going to go ahead and go back to the original equation. This one looks nice and simple. So I'm going to use this equation right here. You should maybe pick a different one and see if we come up with the same answer. So it would be, let's just write that again, x plus y minus z equals 4. And we plug in negative 12 for y, minus 0 for z. So x minus 12 equals 4. Add 12, x equals 16. So there's your answer. The final answer is the point 16, negative 12, and 0. So hopefully that makes sense. I hope you're starting to really like this matrix method. You can get pretty quick at it once you have some practice. You just need to be really careful not to make a mistake, because one wrong number move and you're going to get the wrong answer. And also be really careful with your negative signs. Let's wrap up section 4.2 with this last example. If a building contractor hires 8 day laborers and 1 concrete finisher, his payroll for the day is $15.73. 1 laborer and 6 concrete finishers is $11.66. So let's find the daily wage for each type using matrices. So you could use substitution or elimination to solve this problem. You don't have to use a matrix, or a matrices is the plural of matrix. So my heart wouldn't be broken if you didn't use a matrix to solve this, but since they're asking us to do that, let's go ahead and do that. First, we need 2 equations. 8 day laborers plus 1 concrete finisher gives us a daily payroll of $15.73. 1 laborer and 6 concrete finishers results in a daily cost of $11.66. So there's your 2 equations for this. Let's turn it into a matrix. 8, 1, 1573, 1, 6, 1166. Okie dokie. So the first order of business is to get this to be a 1. And I don't want to divide by 8 because then I get a fraction right here. So let's do something easier. Let's just flip row 1 and row 2. Okay? So that'll be 1, 6, 1166. Scoot this up a bit. And 8, 1, 1573. So there's the new matrix. Okie dokie. So now we need to get a 0 right here. And the way we'll do that is by multiplying by negative 8 and then add down. So we replace row 2 with row 2 plus negative 8 times row 1. So let's do that. So negative 8 times 1, add it down is 0. Well, first off, row 1 doesn't change. Okay. Negative 8 times 1 is negative 8. Add it down, you get a 0. Negative 8 times 6 is negative 48, plus 1 is negative 47. And I'll need the calculator for this. 1166 times negative 8 is that number, plus 1573. Negative 7755. And now we're pretty much there because we have negative 47, Now my times C, because you remember the second column was C and the first column was L. So negative 47 times C is negative 7755. So if we divide both sides by negative 47, we will get C equals, divide this by negative 47, 165. C equals 165. Alrighty then, so now we know what C is, so let's find L. I'm going to use this equation because it has one L. So L plus 6 times C, which is 165, equals 1166. So 165 times 6 is 990. So if I do 1166 minus 990, we get our answer, which is L equals 176. And as usual, for all of these problems, don't forget, you check your answer by plugging in L and C, or into both equations, or by plugging in X, Y, and Z into all three equations. And if it works for all three, you know you got the right answer. So hopefully you have learned to love using a matrix and using an augmented matrix to solve a system of equations. You can use this process, as you can imagine, to solve a system of any size. 50, 500 equations, 500 variables, you could use it to solve it. So I hope you enjoyed this. If you did, please remember to like and subscribe. And if you have a question, leave it in the comments. And I will see you in section 5.3. See you there.